Good morning, everybody. Hope you're having a great day. If you were able to make it to the Tau Day stream yesterday, you'll know what these are for. So welcome to everybody. Welcome back to everybody who saw that. If you weren't, but you were able to see the last contest, you'll be glad to see I'm not going to make the same mistake this time. And also, since this is a Kotlin Heros stream, I decided to move the webcam to the bottom right corner. That way there's a bit more room to see IntelliJ. So yeah, we got that going. We should have decent audio. I managed to turn the fan off because it cooled down a little bit today, so we should be good there. And then we got this Kotlin Heroes contest, which just started. So optimally, I want to try and get top 50 to win a t-shirt. That's the goal. All right, here we go. Vika has decided to go on a trip to Birdtown. She comes to Birdtown on the 8th day. She doesn't want to spend money in hotels, but she has N friends who allow her to stay at their houses. The ith friend, she could say from the 11th day to the 8th day. She decided she would stay at no more than one friend's house. What's the maximum number of days she'll be able to stay? So, just the maximum size of these ranges. Oh, and the first day when she comes. So this is 2 days, this is 4 days. 4 days, okay, gotcha. Yeah, we can do that. So new Kotlin class, this will be a.kt. Another thing I wanted to mention here, well, I'll mention it in a bit. So it's the number of test cases. Okay, so val t equals read line dot to int. So then we have n and k. So val nk equals read line dot map or dot split on a space dot map with that to int. Make this bigger for you guys. There we go. Can I do this or no? I guess not. Okay, so val n equals parts at 0. And then k equals parts at 1. Yeah, I guess let me finish this problem and then I'll talk about what I wanted to mention here. So then we read in n lines. Looks like it. So for, I guess, var ans equals 0. So then repeat n times. We want to read in the L and the R. So val parts equals read line dot split on a space dot map dot to int. I guess this would be parts 2. So if parts 2 at 0 is greater than k, then we can't do anything. Otherwise, we can stay up until r. So ants equals max of ants and parts 2 at 1 minus k. And then we want to print line the answer at the end. Okay, so yeah, this needs to be this plus 1 actually. So what I wanted to mention is about using Kotlin for this. I know I could just use Java, and it would be very easy in that sense, but I feel like it's kind of fun to use Kotlin. It's very enjoyable. So I'm going to try actually using Kotlin. Actually like coding in Kotlin rather than using Java and then converting. Awesome. There we go. We got A, nearest point function. Your friend has created a nearest point function for a given array of integers, sorted in ascending order without duplicates. A point y, we can find the nearest point x to point y. So the absolute difference is minimum possible. Yep. It's a bit buggy though, and there are several nearest points to the given one. It crashes. Okay. So in the given case, for y equals 6, yep, it crashes. Determine if it's possible to cause the function to crash by choosing some integer y. So are all the differences odd? Here's 2. Yes. Yeah. Okay. And then is it sorted? Yeah. Nice. So val t read line split or read line I guess back to and repeat t. Then we need our a. So read line and then I guess we want n. So n will be read line dot to int. And then we'll have our array read line dot split on a space dot map a dot to int. And then we'll say for I in 0 until n minus 1. Then we'll say there works equals true. Print line. So if it works, we print yes, otherwise no. So if works, yes, else no. Okay, and then if a at I plus 1 minus a at I, if this mod 2 is, if it's even, then we have an issue. Or equals 0. So if they're an even distance apart, then works equals false. How do I have this backwards? Then if they're an even distance apart, it's not possible. Oh, this is if it can crash. Okay. Yeah. Looks good. Not if it works. Okay. Move on to sweets. Anya came to her friend's birthday party with n delicious sweets and a circular table. Howdy. For convenience, we'll number them 1 to n in clockwise order. However, eating sweets in some random order is too boring. Wait, what? For each sweet, okay, she should eat all the sweets that are on the table, and she likes them. Gotcha. However, eating all the sweets in a random order is too boring, so she came up with a game that will make the process of eating sweets more interesting. It's played according to the following rules. If there are no sweets, the game's over. At the very beginning of the game, if there is at least one sweet she wants to eat, she will eat sweet number 1. After she's eaten some sweet, she counts k sweets clockwise, starting from the nearest sweet in the circle, and the kth sweet in the count. If there are less than k sweets in the circle, and some sweets can participate in the count more than once, then the last sweet in the count is picked. She likes 4, 5, and 6, and k equals 4. She chooses 1. She eats 1 after these are on the table. then she counts 4 sweets. So 1, 2, 3, 4. So she eats 5. Okay. Then she starts at 6. So this is the game with the people in the room where you shoot the K next person, or the K next the what is it called? It's like some name, Josephus game. I think this is a Josephus game. Okay. Sum of n doesn't exceed 5,000. Okay, so the number of sweets she eats. Oh, interesting. So we can just simulate it, I think. So she eats 1, and then we keep going. Yeah. Okay, let's do it. So we'll have some fun go. At, which will be an int, and then line, which will be maybe a string. Can we do a string? Yeah, yes, that's fine. We'll make it a string. Okay. So, if not line dot contains a 0, then I guess this needs to return an int, huh? Then return 0. Else. Otherwise, return 1. Is that our only error here? Okay, good. So otherwise, val next position. Oh, we also need k. Next position will be at plus k mod line dot length. So then we want val next line. This will be line dot substring. Subsequence. Oh, substring before. Oh, that's nice. Substring before. Okay, we can't do that. I think this is just the same as Java though. So from 0 up until next position. It's inclusive, exclusive. Yeah, okay. Plus line dot substring at next position plus 1. All right, and then val next at equals next position. I think just next position should be fine because we remove it. Mod next line dot length. Okay, so return go at next line and then k. Awesome. Do we have multiple test cases? We do. So val t equals read line dot to int. Then we have val dot map is back to it. So we have n and k, and then we have the line. So val line equals read line. Repeat this t times, and then each time we want to say just do this. So val ants equals go, pass in the line, pass in position 0. Oh, I guess line. Ooh, interesting. So we want to, I guess position will be negative. Yeah, so we eat this one first. So pass in line, we start, oh, where are we at? So we're at negative k. All right, then pass in the line. We pass in k. Then print line the ants. I think we should be good. So let's try this. Divide by 0. Why are we dividing? Oh. Okay, I guess we can just do this. Not even close. Okay. Oh, next stat. All right. Kotlin's so clean. It's the greatest. Okay. So we remove 0. Wait, what is going on here? So you remove k steps ahead of you. Then you pass in next position. Yeah, and what is k? K should be 4. K is 4. So remove position 0, then position 4. Yeah. And then position 1, 2, 3, 4. So you're at position 0. This is a bit confusing. Okay. So we're at 0. We remove 4. So 0, 1, 2, 3. Oh, do we add k minus 1? Yeah, I guess we add k minus 1. And then this is minus k plus 1. Okay. No, not right. Move 0. Then you remove position 0, 1, 2, 3. Okay, now you're at position 4. Which is really position 0, 1, 2, 3. So now you're at position 3. Oh, if it contains 1. Okay, we're still good there. Yeah, 4405 looks good. Okay. Should be fine. Time limit wise, I don't think we'll have an issue. Might not be great, but I guess we'll see. Okay, on to problem D here. String searching. We have an array S of n different strings. Each string has m lowercase Latin letters. We have a bunch of queries. Each query contains a string T. We got it. Nice, nice. Contains a string T of length m plus 1. Okay. Count the number of indices I such that T can be obtained from the string S of I if it is allowed to insert one letter in an arbitrary position. So we have n strings. Each one is short. So we have n short strings. Then we have to respond to Q queries. So each time we're given a string T, and then it's how many strings S exist if we remove one letter from T. So there are 10 ways of doing that. We'll try each. Yeah, so we can just do a hash set. 0 is a bit late, but we're good there. D.kt. All right. Fun main. I'm having fun. Are you? I hope so. N and M. Okay, so this is single thing equals read line dot split on a space. All right. So val n equals parts at 0. Val len equals parts at 1. I guess we'll just call this m. Doesn't hurt. Okay, so now we need to read in the n strings. So val hm, so your hash map equals hash map string to integer, and then we'll say repeat n times. Well, okay, so now we'll have, yeah, I guess repeat n times. So read line then hm at line equals hm dot get or default line 0 plus 1. What? Oh, dot map dot to int. What's wrong with this? Getter default. Line should be a string. Okay, what's wrong with this? Why? How is x any? It's an int. Okay. If hm dot contains key line and hm at line plus plus equals hm at line what the heck? Is not how you do hash maps? Oh. Silly me. Okay. That's an annoying mistake. Otherwise, hm at line equals 1. Alright, cool. So, now, what are we doing here? Yep, so now repeat. What's the, okay, now we have the number of queries. Yeah. So val nq equals read line dot to int. So now I need to go through each query. So repeat nq. For each of these things, so val line equals read line. So then for I in range 0 up until, or for I in 0 until, what's it called? M. So now we'll have our var ans equals 0. We'll print that here, and then we'll have val query equals line dot substring from 0 up until I plus line dot substring at I plus 1. And then we'll say ans dot, or ans plus equals hm dot get or default. What do we want to get? We get query or 0. Add that to our answer, and print the answer at the end. Looks good. So the first one, I'll print the number of indices. Gotcha. Okay, so we can just do a hash set of this. So yeah, val hs equals hash set of string. Okay, so if not hs dot contains query, otherwise hs dot thank you for the nice test case. The real question is, how are we going to be looking on time when we submit this? All right. And problem E here, I guess. Chess team forming. Polycarp is coaching a team for an upcoming game at a chess tournament. Looks like we got it. Nice, nice. A complete team for the tournament should consist of n+1 members. There are n members on his team. The ith member has some skill level. Polycarp is yet to choose the final member of his team. The opposing team has n+1 members, and the jth member has skill level bi. He has n options for the final player. The kth has skill level c sub k. Before the game starts, he pairs up members of his team with the opposing team. Each member of both teams is in exactly one pair. The difficulty of a game for a certain player is the difference between his paired opponent's skill and his own skill. Okay. Yeah. The difficulty of the game is the maximum difficulty for all its players. So before the game starts, Polycarp wants to pair up the players in such a way that the difficulty of the game of his team is minimized. So it's the max difficulty between you and any of your opponents. Am I understanding that correctly? Yeah, so keep yours sorted and keep his sorted. I guess start with that. Then you have a bunch of queries. So the query is like, yeah. Wow, they're all different. That's a lot of different things. Okay, let's look at, this is actually a very good example, so let's look at this for a moment. So we have 10, 10, well, okay, let's do them in order. We have 1, 3, 4, 6, 10, and then we have 9, we have 9, 9, 8, 5, 4, 2, 5, 4, 2. So what's going to happen, you obviously keep them in sorted order. Yeah, you keep them in sorted order. Yeah. Greedy principle, of course. And then you want to you're going to insert this somewhere. So let's say you insert it here. If we do that, we're going to have the maximum of this plus the max of this plus this. Yeah. So we need to be able to query these three things quickly. Let's do that. Yeah, so I could do this in Java, and I'd be a bit more comfortable doing that, but yeah, you know, it's not as fun, right? And I like getting a t-shirt, but you know, it's not the end of the world if I don't, and really, my goal here is to learn Kotlin and get better at Kotlin, you know, so I think that's fine for me. All right, so val n equals readline dot to int. And then we have A and B, so this is fun main. Okay. Oh, so then we're actually just given the queries. Yeah, okay. So then val queries equals readline dot split on space dot map it dot to int. All right. Okay, so now what do we need to do here? So we need 3 arrays. Yeah, so we need val prefix max diff equals int array of size n. Then we need suffix max diff. All right, so for I in 0 until n, prefix max diff at I. Well, so prefix max diff at 0 equals b at 0 minus a at 0. And then for everything else, so prefix max diff at I minus 1, or b at I minus a at I. Okay, this should not be capitalized. So now suffix max diff at n minus 1 equals b at n minus a at n minus 1. And then for I in n minus 2 down to 0. okay, as expected. Down to 0. Then we say suffix max diff at I equals max of suffix max diff at I plus 1, or b at I plus 1 minus a at I. All right, should be good there. So now we need to answer these queries. So let's do that. We just need the value. Okay, so we need val, I guess x equals read line. Oh, equals. I guess this is just a query. Okay, so now we need the index of x. So yeah. So I guess we'll have var L equals 0, R equals n minus 1. So while L is not equal to R, val mid equals L plus 1, or L plus R over 2. If A at X is less than, or A at mid is less than X, then L equals mid plus 1, else R equals mid. Cool. So now the split point is L, I guess we'll say. All right, this is, need more space, okay. The split point is L. So now, val max equals max between some ints. So it will be prefix max diff. How many are we taking? We take L things. Oh, wait. Okay, so get the index of yeah, it would be helpful if this were one bigger. Make these n plus 1 each. Okay, and then subtract 1 from each of these. And then we'll make this n plus 1 as well. And we'll just start this at n minus 1. So we can go overboard by 1 here. Okay, so now we want the index of something else. We want the index of the first thing less than x. First thing greater than or equal to x. First thing less than x would be easier. Well, first thing greater than or equal to x, that'll be x's position. Yeah. All right, so do we calculate this right? I think we do actually, but this might be n. All right, so the new index will be L. So this will be prefix max diff at L minus 1. Or the max of the suffix max diff at L plus 1 at L, yep. Or B at L minus X. Print line the max. Is that right? I think it might be right. Not totally sure, but we can see. Right next out of bounds -1. So in this case, L is 0. Oh, this is plus 1, so it's just L. we need to sort them. Dot to int array, to int array, a dot sort, b dot sort. Four two three 4 2 looks good, just the wrong format. So print line over here, and then print max. Looks good. Submit E real quick. And I think we'll move on to F. Alright. Let's call a string T consisting of characters. Wrong answer, test 3. That's annoying. Ooh, that's really annoying. Okay. So I guess we don't need this. So our binary search, right? So we want the index of the first thing greater than or equal to x. So well, these are different. We get some index. Oh my goodness, there are 3 samples. Yeah, okay. Int dot min value. This might help. That was a really stupid wrong answer too, from not running all the samples. Let's run this sample, just to make sure we got it. Looks right, and then this one finally. Our binary search did look right though. All right. We have a string of characters 0 and 1. Our answer test 4. So now the first non-sample we're getting wrong. So what part would we be getting wrong here? Say we have n is 1. We have one guy at 5. He has 2 and 10. Well, 2 and 7. Let's say we have 3 queries. 0. 4. So if it's 0, then the difficulty would be 0 or 4 doesn't matter. If it's 0, I guess the difficulty would be 2. If it's 4, the difficulty would also be 2. And if it's 10, difficulty would be, if it's 19, the difficulty would be -3. Okay. Prefix max diff at, well, so it looks like we broke it. This is index 1, as it should be. Yep. Prefix max diff at 1 should be b at 0 minus a at 0. B at 0 minus a at 0. B at 0 is 2, a at 0 is 5. Right. 2 minus 5 is -3. That's wrong. What? Whichever's bigger, this or oh, it should be 1 dot dot. -3, that's right, okay. This is not very helpful. Also, I didn't even run samples. So that might not hurt. 0 minus 5. There we go. So we got it. All right, cool, cool, cool. How are we doing? 45th place. So yeah, not great, but still possible to win a t-shirt. We gotta keep going though, for sure. Let's call a string T consisting of characters 0 and 1 beautiful if either the number of occurrences of 0 in this string does not exceed k, or the number of occurrences of 1 does not exceed k, or both. So if k equals 3, has to be at most 6 long. This works. Gotcha. Wait, this is beautiful. Oh, so it can be very long. Gotcha. All right. We're given a string S. We need to divide it into the minimum possible number of beautiful strings. Yeah, such that everyone is beautiful. For each k from 1 to s, find the minimum possible number of strings that s can be divided into them. I see. Okay, so for each one. So if s equals 1, they're saying there are 2 strings. Oh, 1, 2. Gotcha. Yeah, so we could do binary lifting, right? We can say if we take, you just need to know when the next changes, right? So you can unify everything, and then we need, well, what if we just unify everything? Yeah, you can compress things, right? No, you can't. Yeah, you can't. So if we say, okay, let's say we're at some position, and then we say, what if we go k zeros forward? If we skip k zeros. So like, when is the next 0? And then when is the next 1? We need to know these. And then we need to know when is, like, if we, the second next 0, the 4th next 0, the 8th next 0, etc. So if we have all of these, we can say if we take k next 0 steps, where do we end up? Yeah. Then our runtime will be n log squared. Because this will be harmonic. Ooh, will it be harmonic? Yeah, it'll be harmonic. So if we're taking steps of size 1, it'll take n over 1, worst case. 2 will be n over 2, worst case. 3 is n over 3. So the sum of these things is n log n. So that's not too bad. And then, yeah, so this is how many times we'll do a binary lift. And the binary lifting costs log n. We can make the binary lifting faster, though. If we just store what's the index of the kth 1, kth 0, and then of the kth 1, then we can get rid of this log. And then also, I guess, what is your index? So we can go backwards. So we need the index of the kth 0, index of the kth 1, and then what is your index? Is it a binary string? Yeah, binary string, okay. Yeah, so we'll have the index of each 0 and each 1, and then we want to know what our index is. Is that it? I think that's it. So now it's going to be n log n, which is better. Yeah. Okay, so we're going to do this for each value. For each value, we say, would we skip by 0 or 1, and then do that. Sounds good. All right, so this is, we just read in the line. Cool. So now we need val n equals line dot length. Then we need int or val count of count, I guess, at me equals int array of size n. So then for, I guess we want, so then we need val index of 0 count. Oh, I guess, so var 0 count equals 0. And then line dot for each. If it equals 0, then 0 count plus plus. There's a cleaner way to do this for sure, but can we do line dot count? Oh man, it dot count it equals 0. Never mind. I don't know. Okay. So we count the number of zeros. So now val 1 count equals, oh, 1 count will be n minus 0 count. And then we can say we need val index of kth 0 equals int array of size 0 count, and then we need the same thing for ones. Kth 1. Then 0 count equals 0, 1 count equals 1. and for I in 0 until n, if line at I is equal to 0, then 0 count plus plus, else 1 count plus plus. Then index of kth 0 at 0 count equals I. And count at me at I equals 0 count. And otherwise, index of kth 1 at 1 count equals I, and then count at me at I equals 1 count. Good. All right, so we're fine there. So now we need to answer the queries. So for I in 1 until n. I guess this is jump by. So yeah, var at will initially be 0, and then var steps equals 0, and print steps plus a space, and then print line at the end. Okay, so what are we doing here? We need to keep jumping by this amount until we can't anymore. So yeah, so I guess we need our current index. So if at, or if line at is equal to 0, then we do the 0 case, else we do the 1 case. Well, it doesn't matter. Yeah, it really doesn't matter. We need the 0 count and the 1 count for each of these things. All right, so now count at me at I equals 0 count, and then 1 count at me at I equals 1 count. All right, so this will be, assume we haven't counted this index. All right, so int or val start 0 count equals 0 count at me at start 1 count equals 1 count at the start. Okay, so now we want to say, can we finish it? So if I guess this is a while true here. So if start z count plus jump by is less than or equal to 1 count, or is greater than or equal to 1 count, then break. Oh, I guess in this case we do steps plus plus. Same thing if we can get all the 1s. Yeah. What if we can't? Then we need to move to whichever is bigger, the next 1 we can't get or the next 0 we can't get. So val next z will be 1 index of kth 1 at start 1 count plus jump by plus 1. And this will be next 1 will be index of next. This needs to be next. Yeah, so this is next 1. This is next 0. So index of kth 0 at start 0 count plus jump by plus 1. Okay, so then at equals whichever's bigger, next 0, or next 1, or next 0. I think we should be good. All right, nice. Why is 1 count 2? 1 count equals 0. Greater than or equal to 0 count. Okay, this doesn't make sense. Yeah. So let's say the start 0 count is like 3. So we've seen 3 zeros. And then we're jumping by 2. Right? We can have at most 2 in it. Yeah, so we jump by 2. So the index is 0, 1, 2, 3. Index 3 plus 2. The next thing we would hit would be this plus 2. So no plus 1 here. Okay, looks good. Let's run the other sample, learn our lesson here. Should always be decreasing, but we don't abuse that. Okay, I'm pretty sure it's n log n, so let's submit. Nope, not E. F. Okay. Nice. How's it looking? 39th? Moving up a little bit in the world. Ah, now time for the real problems. Okay. Alright, those 2 wrong answers might kill me. That's going to be a problem. Alright, problem G. Oofda. Yikes. Tough problem, tough problem. Polygraph decided to generate a biome map for his game. A map is a matrix divided into 1 by 1 cells. Each cell in the map must contain one of the available biomes. Each biome is defined by 2 parameters, a temperature and a humidity. But for every temperature and humidity combination, a corresponding biome is available. Biome map should be generated according to the following rules. Oh, but not every combination has a corresponding biome. Okay. Each cell in the map belongs to exactly 1 biome. Each available biome has at least 1 cell on the map. Each cell on the map has one biome. Each biome has at least one cell. Okay. Okay. If two cells in the map are adjacent by the side and they belong to biomes with parameters these, oh, then you can change, yeah, you can change either but not both by 1. Let the number of biomes be equal to k, and let the total number of rows and columns in the map should not exceed k. The number of available biomes be equal to k. K available biomes. Then the number of rows on the map should be less than or equal to k. Oh, but not for every combination. What now? How many wrong submissions are there to this? There are 0 wrong submissions to it. Okay, I'm gonna get a Cliff Bar because I think this is like trivial. Alright, I do not understand what this problem is asking at all. So we have this big matrix. Alright, sorry for the fan noise. It's super hot in here. I guess we can do the classic this thing. There you go. Maybe that's better. So we've got this big matrix. And okay, each cell on the map should belong to exactly one biome. Yeah, each available biome has one cell on the map. So what are the biomes? Are we given all of them? So the following n lines contain n integers for each temperature. So this is the biome identifier with the parameter this. Oh, otherwise it might not be available. Okay. So 2 by 3. So these are the 3 ones that are available. So label the things 1, 2, and 5. Oh, and then you come up with some map. There's a duplicate here. So the width has to be equal to oh, gotcha. So we make it like k by k. Got it. Got it. Okay, so we have this map here. We want to like transpose it onto this map. What if it's not possible? Print -1 if there's no map that meets all the conditions. So if this isn't a connected component, then it's not possible. Right? It's got to be connected. And if it is connected, we can just replace zeros with one of the things diagonal to it. Like, can we not just... So we have 0, 2, 5, 0, 1, 0. Right, we'll just make something of the same size, and then we'll just put a 2 here. Oh, well, maybe that's not possible. Yeah, that doesn't always work. Let's see. You could have something like this. You could have like A, B, C, D, E, F, G, H. So this needs to have one of these things, and it also needs to have one of these things. Yeah, so if you ever have this, then you're in trouble. What if you ever have a hole? If you ever have a hole, are you in trouble? Are you in a lot of big problems here? Like, if you have, oh, well, no, so this is possible. In this case, we can do just one line. We have an Euler tour. Can you always do an Euler tour through a graph? Not always. Yeah, this one you probably can't, right? So this is odd degree, this is odd degree, this is odd degree. What else? This is odd degree, yeah. So you can't do an Euler tour through this. So what happens when you can't do an Euler tour? Oh, I guess we have every biome by every other biome. So A can only pair up with B and H. And these two, everything has 4 things that can be adjacent to it. So well, the map is 2 colorable, right? Each biome, yeah. So we have like 2 different types of biomes. We've got some red ones, and then we have some white ones. And we've got some edges, but they're like, I don't know, interesting edges or whatever. So now we have what if we did this? Okay, alright, hold up. So we connect this one. This goes here. Yeah, so we do this. Alright, and then the red would connect each of these like this, or each of the ones that it can connect. You might not be able to connect 2 of them. Yeah, there are really only 2 of these things that can be connected by a red, or there are 4. That can be connected by a red. So so we just need to extract this. We just need to, like, this already works, right? We just need to make a version of this map with no zeros. That's too big. It's too big to think about. What if we did this? Okay. So we can go. We could put these in like a line. Now what happens if we can't, what happens if we've got like a bad graph? So we could have something like something without an Euler tour. Yes, that's a good one. Yeah, so now we would start somewhere. Maybe we start at this one here. So we have this, 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 this. And then we have like a red. So in order for this to stop, that means there's nothing here, there's nothing here. So that means this one is done. So these three are not going to be used. So can we continue in this direction and in this direction? So now we have this red, so we put a red here. And we continue, we like start going here. We start DFSing here. So then we use this, and then this stops, so it doesn't use these three. Oops, not there. We would put the red here. So it doesn't use this, this, or this. Yeah, okay, so we do a DFS. So it's a DFS. And then every time we have no kids, like for your second kid, then you change direction. Second kid is like plus, and then third is minus. Yeah, okay, I think that's good. All right, that's a bit messy, but I think we can do it. All right, new class, this is f.kt. G, so many problems, g.kt, okay. Multi-test case? Yeah. So this is the height and then width. Okay, so all right, so then we have val height equals parts at 0, val width equals parts at 1. Then we need the grid. So array of int array. What's this? It's gonna be, we'll do width, and then each one of these is an array, or an int array of size, oh man, this is easier. So height by, this will be int array of width, yeah, of read line dot split on a space dot map it dot to int array. Look at how easy this is. Okay, val map equals, this is like 4 lines of code in Java. So easy, so easy. Okay, so we have so it's height by width, so it's yx, which is not how I usually do it, but it's much better for this problem. Okay, so now we need to DFS. All right, so we need val dx equals int array of 0, 0, -1, 1, I guess. Oh, we probably want, these should go in circular order, so it should be, let's say, right, left, right, let's say up, right, down, left. Okay. So up has no x, right is 1, down is 0, left is -1. dy up is -1, right is 0, down is 1, left is 0. Okay. So we have this DFS. So we also need a Boolean array. So val visited equals array of Boolean array of height, and then each one is a Boolean array of width. So we'll need a map, which is an array of int array, and then we'll need a visited, which is an array of Boolean array, and then we'll need a couple things. So we'll need a map x, map y. Map direction shouldn't matter too much. Array of Boolean arrays. Yeah, I guess let's figure this out a bit better. So we do this DFS. Can we always just DFS right? Oh, this will wind up with extra space, though. Yeah, this doesn't actually solve the problem. This doesn't solve the problem at all. Because we still have all the space we didn't use in our DFS. We still have. Alright, so for this problem we need to count the number of submatrices with exactly 1, 2, 3, 4, and 5 different letters. So we can iterate through each subset. How many subsets are there? 2 to the 5, it's 32. 31, I guess, because we don't need an empty. So, yeah, so we want how many matrices are full. So 32 times 800 squared, maybe. So now it's like how many matrices are full? Yeah, so... Well, if we know contain exactly k, what if we say contain, so if we know there are like 10 matrices that have A, B, and C, and then there are 3 matrices that have A and B, and then there are 3 matrices that have A and C, and then there's 1 matrix that has just an A. So that means there are 10 of these, but we want to subtract out 3, and then add in the 1, which we double subtracted. Yeah. So this is going to be 800 squared times 32. Two times 10 is 7, should be fine. Yeah, so we can definitely do this. Let's just solve this problem then, because it's easier. So now we need static, or we need a fun count. So this is a array. Oh, this is okay. So this is the grid, which is an array of Boolean arrays. And then I guess like a width, which is an int, and then a height, which is an int. So how do you do this? It's in count number of full rectangles in order size. That's what this needs to do. Okay, so how do we count the number of full rectangles in a binary grid? These are common problems, probably in Geeks for Geeks. number of rectangles, right? We want the number of rectangles in a binary grid. Unhelpful. Okay, not helpful. All right, let's do it for real. So we have a binary grid. That's an absolutely terrible rectangle. Try again, please. All right, so we have, let's do on some row. On some row. Okay, so now we have some histogram. We have some maximal set of histograms here. We'll have this in a stack, maybe. All right, so now we see something smaller. So now we see this one here. So we need to remove this. So we need to count all of the top right points in here. And then we remove this. We need to count all the top right points in here. And then add this. So we have a stack of top left. And then we remove from the, yeah. So stack of top left, and then we see something and we handle it. Okay. So we need an array of int array, which is the num above array int array. What's the size here? So it'll be width, and then each one of them will be an int array of size height. All right, so now for x in 0 until width, var count equals 0. So then for y in 0 until height, yeah, so then we'll say if grid at x, y, then count plus plus, else count equals 0, num above at x, y equals count. Cool, so now we have this. So now we need to process this thing. Okay, so long ants equals 0. Oh, var ants equals 0. Turn the ants. Okay, so now, yeah, okay, so we have this answer. So now for y in 0 until height. Now we need to maintain the stack. Okay, so we have this stack. So now we need to remove stuff from the stack. So okay, so now this is like, oh, we need to have the height as well. Okay, or we need to go horizontally. So for x in 0 until width. So we'll have val cur height. This will be num above at x, y. So while not stk dot is empty and stk dot peak is greater than cur height. So while we have this, then we need, oh man, what is this? So this is, okay, so this is num above at stk.peak y. Okay. And then later on we'll say stk.push x. Yeah, so while we should be fine here. So okay, so while the stack isn't empty and we need to pop, we need a val dx equals x minus, is it x? Yeah, x minus stk. Okay, so val old x equals stk dot pop. Val dx will be x minus old x. Val dy will be, oh, this is annoying. If we pop twice, it doesn't work right. Or does it? Yeah, it doesn't work right. So the new y will be if stk dot is empty. If the stack is empty, then it'll be cur height. Else it'll be stk dot, or else it'll be max of cur height and stk.peak. Okay, val dy equals, oh, and this is, okay, or this will be num above stk.peak y. Okay, so dy will be stk, oh, this will be, okay, so this will be num above at old x y minus new y. Alright, ans plus equals dx times dy. And then we've removed it from the stack. So we include all of these things. Okay. Greater than or equal to. Alright, so now when the stack isn't empty, what do we do? I guess we could make these all end in a 0, huh? So make this with +1. Make these all 0. +1. Yeah, okay. So that's a hacky get around, but I think that should work. So now that should count the number of rectangles in a grid. Okay. Alright. So we've got that. So what now? So now we read height and then width. Alright. So val parts equals read line dot split on a space dot map it dot to int. Val height equals parts at 0. Val width equals parts at 1. Okay, so now we need the grid. So val. Yeah, this part's width by height. But if we invert it, it doesn't matter, right? So let's make this width and this height. This height. So now we'll have the val grid equals okay, so let's make this. This is a array of char array. It's going to be height tall. Each thing will be, I guess, an array of string. And this will be, just read the line. All right, so now we need to brute force the letters that are allowed. Okay, so yeah. So for mask in 0 until until 1 left shift. I'll shift left 5. So 2 to the 5th, yeah, okay. So Boolean, okay, so val. Okay, so we need the, what is this called? We need the grid. Val grid equals Boolean array, or equals array of Boolean array of, yeah, so this is going to be width big by Boolean array of height big. All right, so then we need to fill in this grid. So for x in 0 until width, for y in 0 until height. So now, okay, so this is the val char will be grid, will be parts, wait, it'll be grid at xy. All right, so if mask contain, and kind of wacky. So if mask and, what is this? This will be char. Okay, let's make this an int. So grid minus dot to int grid at xy. This is a oh. Is it uppercase? A dot to int. then bool grid at xy equals true, else bool grid at xy equals false. Yep, please fix this for me. Thank you. Yeah, looks good. Okay. Mask and char is not equal to 0. Okay. So we have that. Thank you. And then we say ans for mask, and mask equals equals count of the bool grid. All right, so now we need a real ans for mask. So now for super mask in 0 until 1 shift left 5. For submask in 0 until 1 shift left 5. I guess so this will be val count or var count equals ans for mask at super mask. I guess it'll be 0. Yeah, 0. There's gonna be some annoying shenanigans going on here. Okay, anyway. Make these all well, okay. Real ans for mask at super mask will be count, and then to do calculate sum of masks of all types, or of all, yeah, sum of masks by bit counts. All right. Kotlin bit count. Count 1 bits. What is this? Int that count 1 bits. Okay. If int dot submask, not, darn it. Okay, so if submask and supermask equals submask. Well, if it's not equal to this, then continue. All right, so now okay, val bit changes will be int dot 1, what's it called? Count 1 bits. Oh, I can just do that. That's so nice. So this is supermask. Supermask dot count 1 bits. How do I do this? It's experimental. I don't want I want the legit stuff. Since 1.4 was experimental. Yeah, but it's not anymore. Count 1 bits. Okay, I don't know how to use this. Integer dot bit count submask. Can I do this? Yeah. Okay, so that's the bit changes. So if bit changes mod 2 equals 0, then count plus equals count plus equals ans for mask at submask, else count minus equals ans for mask at submask. Okay, looks good. So now we need val answers equals int array of size 6, make it all zeros. For I in 0 until 1 shift left 5. Answers at integer dot bit count I plus equals real ans for mask at I. So much stuff going on here. Okay, now what? So we have this for I in 1 until 1 to 5. Print answers at I plus a space. Print answers at I plus space. There you go, and then print line. This multi-test case? No. Okay. Please come back. Boolean grid and then width and height. Map is never used. Why is map never used? All right, so returning ants line. All right, so for empty thing, return 0. For this, we have 3. We have 1, 2, 3. Is that for the B's? Yeah. Yeah, for the... Wait, why is that B? What about the A's? That's sketchy. What? So mask is 0, that's fine. When mask is 1, this is a problem. So we need to print this grid. How about that? So for y in 0 until height, print line. For x in 0 until width, print grid at x, y. So we have this. This is not the A's. Oh, mask and, yeah, this should be one shift left. Okay. Alright, so it's this. For 0, we get that. For 1s, we get 2. This should not be 2, this should be 3. Yeah, so that's the problem. Okay. How do we fix it? So x equals 1, old x equals 0. Oh, this doesn't work at all. Ugh, okay. Back to basics. When we have a grid, yeah, so how does this work? So we have max it's like the max histogram thing. So if we have this, what do we do? So we probably want to add so we want the last x and then the last y. I guess we could just modify the existing array. How sketchy is that? Probably kind of sketchy. I'll push my X. And then what else? Then we need to modify the height. So then cur height at my X equals, oh, it's not cur height, equals cur height. But Y. This is num above. That is 3. This is 4. 1, 2. This is not 4. Oh, we only care about stuff that ends at this footer. No. Yeah, we do, but oh, it is 4. Yeah, okay. 12. 1, 2, 3. So 6, 5, 7, 8, 9, 10, 11, 12, 13, 14. It's more than 12. So 2 here. Oh, because we need to add. Yeah, this is not right. Okay. Let's do this part the right way here. Okay, so now we'll need a val stack sum, which is initially 0. And then stack count. Yeah. So okay, so this needs to be a long, this 0L. Stack sum is 0. Okay, so now after we do this, we want to say ants plus equals stack sum. All right, good. So int or var count to add equals 0. So while stk not stk dot is empty, and stk dot, well, count to add will always be at least 1. Yeah, just add myself. Yeah. Dot peak is greater than or equal to, we'll just say greater than cur height. In this case, we need to remove, so we need to do stk.pop. Okay, so we removed these. So now stk sum minus equals removed height times removed count. Okay. And then count to add plus equals removed count. So then we need to say stk dot push cur height, and then stk count dot push count to add, and then stk sum dot plus equals count to add times cur height. There you go. 56, 94, 131, 57. Looks good. 78, 153, 99, 00. Okay. Submit. Problem H. All right. Now the real question is this gonna, well, a couple questions. Do we get it right? 56th place. Uh-oh, lots of wrong submits. It's a bit scary. Wrong answer test 1 for real. Ah, silly me. Okay. What am I printing? Right there, okay. Yeah, so lots of people are getting this wrong, which is a bit concerning. Lots of TLEs, lots of TLEs, lots of TLEs, okay. On test 12 too. Are we gonna have to do some silly optimizations? 3.5 seconds. So we're gonna get a TLE in test 12, huh? For real, okay. Well, we can handle this, I think. TLE 12, okay. It's a bit silly. Wait, it's only one test case. Our runtime should be fine. Alright, so we can reuse this Boolean array. That's somewhat of a speed up. Oh, actually, let's just generate max case, huh? So val w equals 800. Val h equals 800. Val grid equals array string w What the heck? So fast. Is it the reading and input part then? So that slows it down. Okay. We won't do that. What if this is a string? Do we just need fast scanner? I guess we can try that. Okay, otherwise it might be this stack stuff. Looks like a tealy again. So yeah, we pop. Should an infinite loop, I don't think. Could it infinite loop? I don't think so. Our runtime should be pretty fast. Oh, I guess. Yeah, no, this part's tiny. This is super quick. TLE 12. Okay, so we run this part 32 times, right? So this is the slow part. What if we did this? Oh, we can't. Another TLE. Do we get it? We got it. All right. So I guess the Java stack was the problem. What are we doing? Not bad. Not bad. How about our friends? How'd Colin do? Colin got G. Nice job. Nice job. Yeah, we should be fine then, I think. Are these TLEs as well? Yeah. The stacks, they'll kill ya. They'll kill ya. I should have known that too. Yeah. Java stacks are the worst. All right. Well, yeah, that's all from me. I got some stuff I have to go do, work-related stuff. So I don't really have time for... What is going on with my screen? Holy cow. Okay. Windows, you're geeking out here. Windows? Is this... What the heck? What is this? What the heck? This is totally a bug in Windows. There's no way this isn't... Are you guys seeing this? Look at what is going on. What? Windows? Excuse me? Alright, yeah, let's try and fix that. There's no way this is intended. This looks so terrible. Windows, please fix your code. Okay. Yeah, that's all for me. I'm not gonna go over solutions because I don't have time. I have to go to work. But have a great day. It's broken again. Okay. Have a great day. Thank you guys for watching, and hopefully you won a t-shirt as well. There we go. Yeah, I think I won one. We should be top 50. Unless I don't know, I fail system test or something. It looks pretty good. Because it's unlikely lots of people solve that many problems in that short of a time span. So, should be good. Nice job to Peter for the first place. I wonder if this is Java conversion. It might be. That's okay. Doesn't hurt. Tourist, I think, usually does it in Kotlin legit. So good job to him. But yeah, that's all. Thank you for watching, and have a great day. Goodbye.